some proof, what is the basics about circle, sector, arc, all that is what we saw, right? And we did one proof also. Today, we have few more things. So in the last class, which theorem we learned? Anyone remember the theorem that we discussed? What was the theorem that we discussed? So it's like whenever you have a circle, from the center of the circle, if
and
I am...
Theorem 22.
Yeah. So whenever I'm drawing a straight line from the center of the circle to a chord, it will always be perpendicular. Okay, so this is one rule that you should be remembering. This is from the center, a straight line drawn from the center of the circle. Okay, a straight line, I'm just telling you this thing, a straight line drawn from the center of the circle. The circle does two things. What are they? One is bisects the chord. Second one is it's perpendicular. It is at right angles to the chord. Okay. To the chord. So these are the two things that you should be remembering, provided the chord is not a diameter. This is chord is not the diameter. So this is what we discussed and proved in the last class. So today we will see the next thing, next theorem. Now, if I am drawing, see, if from the center of the circle, okay, if the distance is more, that means to the chord, the distance is more, what does it mean? Distance from the center to the chord is far, right? So what is it? Depends on the size of the chord, you can understand. Here, the chord will be the longest because that's the diameter. Diameter will be the diameter is the longest chord. When the distance from the center to the chord is increasing, the size of the chord is actually decreasing. Understood that or not? So this is not a diameter. So this distance is actually very less, right? Are you all understanding this? This distance is very small, assuming this is just 2 centimeters. And this distance is, different color I'm giving. This distance is, say, 5 centimeters. So 5 centimeters from the center of the circle is more. It is higher distance. So when the distance is high, the size of the chord will reduce. Understood? Is that clear? So here you can write that point as greater is the size of the chord. Greater is the size of the chord. Smaller is the distance from the center. And vice versa. Okay. Next theorem is equal chords of a circle are equidistant from the center. What does it mean? What is the meaning of equal chords?
The chords are equal.
Yes, the length of the chords are. Oh, my circle is really bad. Okay. Oh. Anyway, I hope you understood this is a circle. So if this is from the center of the circle, if this is, say, the length of the chord is 5 centimeters, and here also the length of the chord is 5 centimeters, Okay, the distance from center to the code.
Will be the same.
Yes, so OP and OQ, OP will be equal to OQ if what? AB equal to CD. Understood? If the length of the codes are same, then the distance from the center to the codes will be same. Is that clear or not? Nalin, are you getting this?
Yes, ma'am.
Yes, ma'am.
Okay, so we will try this proof. So what we did here, did you all understand what I did here? So we drew a circle with center O. From AB and CD are two codes, two equal codes. They are of equal length, so they are equal codes. And then from O, you're drawing a perpendicular to code AB. Similarly, from O, you're drawing a perpendicular to CD. Okay. Now, what is it that you have to prove? You have to prove that when AB and CD are equal codes, OP and OQ will be equal. Okay. To prove that, we need to do some construction, and what we are joining OB and OD, which are the radius. Okay. So this is what we have discussed. Now let's do the proving part. So here, what are the statements? So here, this side is recent. Okay, so BP, what is BP? BP will be half AB. Is it correct? How can I say BP equal to half AB? Can you tell me? I'm saying BP is equal to half AB. Eva, tell me. How can I say BP equal to half AB?
One second. PP equals half. Because the perpendicular OP, the line OP is perpendicular to the
Code,
chord
yes.
AB.
So we just, in the last class, we learned perpendicular from the center will bisect a chord, right? Depending on that or based on that, we have this. Okay, so the reason we will write perpendicular from the center, perpendicular from the center bisects the chord. Okay, next one. Similarly, can I do for DQ? DQ is also same thing, right? Half of CD. DQ is equal to half of CD. Same thing. Perpendicular from the center bisects the chord. Now, AB and can I write AB equal to CD? Can I write AB equal to CD? Hello. Are you guys with me?
Yes, ma'am.
Yes,
AB
ma'am.
equal to CD. Why? Because it's given.
It's given.
Yes, it's given. So now based on that, can we write BP is equal to D, BP is equal to DQ. How? From 1, 2, and 3, which is 1, 2, and 3. The first 3 points, 1, 2, 3. Based on the first 3 points, we are proving that BP and DQ are same. Understood or not? How can you prove that? BP is half AB. See here you have one line. This is one line. AB is here. CD is here. I'm saying that BP, this is BP, this is DQ, DQ. Okay. This line and this line are PB. What I have written, PB is half of AB. And here I have written DQ is half of CD. Then I am writing AB and CD are equal. Then don't you think it's, PB and QD are equal? Doesn't it make sense? Are you getting this?
Yes, ma'am.
Huh? That's all. So Eva and Shreya, no response.
Yes,
You
ma'am.
understood, right?
Yes, yes.
Yes, ma'am.
Okay. Next point is we need to consider the triangle now. Okay. So now fifth point is triangle OPB. Okay. And triangle OQD. What is OPB and OQD? OPB and OQD. Which are the triangle? This triangle and this triangle. We just need to show that they are congruent. Okay. So OPB and OQD. Don't you think angle OPB is 90 degree here? It's 90 degree, right? Because it's perpendicular.
Yes, it's perpendicular.
So it's and OB and OD are equal because they are radii. Is it not?
Yes,
OB,
ma'am.
OB and the OD are radii of the circle. Now, what about we know BP and DQ are same. That also we have proved. Just now we have proved those two are equal. Now, can we say that based on RHS rule, they are congruent? These two triangles are congruent. Does it make sense? Are they or not?
Yes, ma'am.
Nalin, I'm not getting a,
Understood.
understood. Okay. So here, so I'll write whatever the given information and what we understood, we will write here. So in this triangle, first point is what? BP and DQ are same. BP and DQ are same from where? From fourth point. Now second subdivision is OB and OD are same because that is the radii of the same circle. They are radii of the same circle. Now third point is our 90 degree one. Angle OPB and angle OQD are 90 degree because OP is perpendicular to AB and OQ is perpendicular to CD. Because of that, this is 90 degree. Now what are we saying? A triangle OPB is congruent to triangle OQD by RHS rule. Now, since they are congruent, can we write when they are congruent, the third side, which is silent, will also be, this side will be congruent, right? Automatically, because of congruency, we can say OP and OQ are same, right? So, therefore, we can write OP equal to OQ by CPCTC. Okay, hence proved. That's it. So please write this down quickly. Just tell me if you want me to scroll up or down. So we have a converse for this that I'm not proving here, but you can just note it down. So here, chords of a circle, equidistant from the center of the circle are equal. The same thing what I explained here, it's going to be, what we are saying is the chords of a circle equidistant from the center are equal. Earlier, the given information was they were equal. You had to prove that they are equidistant from the center. But here, they are giving you that the chords are equidistant. You have to prove the chords are equal. Okay. So this one I'm not proving. You can just check it from your textbook. If you have noted down, I'll move on to the next one.
Ma'am, can you scroll up a bit?
This is fine?
Done, ma'am.
Yes,
Yeah.
ma'am.
Okay, 1 minute. Okay, so next theorem, let us discuss then. Next theorem is, there is one and only one. There is one and only one circle which passes through three given points not in a straight line. There is one and only one circle which passes through the given points not in a straight line. Which passes through three. Okay, this is three.
Ma'am, three given points.
Three given points not in a straight line.
Okay.
So what are the given information here? 3 points, right? You are given 3 points. 3 points A, B, and C, which are not in a straight line. This is what is given. 3 points not in a straight line. That's what is given to you. Now, what is it that you are asked to prove? What is it that you have to prove here? That only one circle, one and only one circle, one and only one circle can be drawn through, only one circle can be drawn through A, B, and C. Okay, this is what you're going to prove. So basically, you should be having 3 points like this: 1, 2, 3 here. Okay. And this is going to be my A, B, and C. Then I'm joining AB and BC. I'm joining AB and BC. Okay. Now I need to draw a perpendicular bisector of AB and BC. I need to draw a perpendicular bisector of AB and BC. Perpendicular bisector of AB means from AB I'm drawing a perpendicular. From BC also I need to draw a perpendicular. Okay. So this is the perpendicular bisectors of AB and BC. Perpendicular bisector means this is going to be 90 degree. That's all. And now this joining point I'm marking as O. Okay, so we have to do some bit of construction. That's what I have done here. So construction is what? Construction is join AB and BC. Draw perpendicular bisectors of AB and BC. Let these bisectors meet at point O. This is clear? Till this point, are you all clear? Any doubts you have? Let's start with the proving part now. Let's start with the proof. For proof, you have to write statement and reason.
May not write the circle.
No, I am not drawing the circle right now because what they have told you is 3 given points. Only 3 points are given. Circle is not yet given, right? You only have 3 points. And from that 3 points, I have just done construction. That construction is drawing perpendicular bisectors and meeting those perpendicular bisectors at point O. They have not explained, they have not told me there is a circle. So I'm not drawing a circle at the moment. Okay. Let's see, because what they are saying is only one circle can be drawn at the max through 3 points. Let's see how they are proving it. Okay. So what are the statements? Since O is the perpendicular bisector of OB, can you say this OA and OB, OA and OB, will that be same? Will OA and OB be same? That's my question. If you're not understanding, you should tell me. See, I have a perpendicular, okay? I have a perpendicular here, like this. This is O. This is AB, okay? Now, AB is what? AB is, say, 5 centimeter long. So this point, when I say perpendicular bisector, this point is exactly 2.5. Is it not? Are you agreeing or not? 2.5 centimeter, it will be the perpendicular bisector means what? Exact midpoint, right? So perpendicular bisector is exact midpoints, a straight line cutting AB into 2 equal halves. That is what is meant by perpendicular bisector. So when O, what is it? O, O is a perpendicular bisector. Don't you think from O, distance to A and distance to B will be same?
Yes, ma'am.
Logically, it is correct, right? So that's what they are saying here. As first point, since O lies on perpendicular bisector, OA will be equal to OB. Okay. If you are not understanding, any of you have doubt, please do ask. So it's reason. What are we going to write? The reason. Each point on the perpendicular, each point of the perpendicular bisector is equidistant from the extremities of the line. From the extremities of the line. What does that mean? That means this is one point on the perpendicular bisector. This is another point on the perpendicular bisector. These are all different points on the perpendicular bisector. From any point, if I connect A and B, all this point, OA and OB will be same. Any point, from any point I take and join that point with A and B, that point to the distance from that point to A and distance from that point to B will remain the same. That's what they are writing here. Each point of the perpendicular bisector is equidistant from the extremities of the line. Extremities means what? Descent and descent. That is extremities of the line. Understood? Second point is now O is lying on the perpendicular bisector. Again, I have to write the same thing. Since O lies on perpendicular bisector of BC, I can write OB is equal to OC. Can I write like that? OB equal to OC. OB and OC are same. Can I write like that? BC. See, AB is one line, BC is another line. Understood? AB is one line and BC is another line. So AB means O is a point. So from O, distance from O to A and O to B will be same. Okay. Similarly, O is again the perpendicular bisector for BC. Okay. Now from O, the distance to B and C will remain same because it is B and C are extremities of that line, of the line BC. Understood? So OB and OC will remain the same. Are you understanding?
Yes, ma'am.
Yeah. Shreya, you're clear with this?
Yes, ma'am.
Okay. So now I'm writing, say, since O lies on perpendicular bisector of BC, OB is equal to OC. Same reasoning I have to write. Each point of the perpendicular bisector is equidistant from the extremities of the line. So the same point that I wrote for the first point, I have to write for the second point also. Okay, now what is these two implies? From 1 and 2, can I say OA equal to OB equal to OC? From the first 2 points, if I combine the first 2 points, I'll get OA equal to OB equal to OC, right? What does that mean? Implies O is equidistant from O. O is equidistant from A, B, and C. Right? OA equal to OB equal to OC means O is the common point. So O is having the same distance to A, B, and C. Getting it or not? Okay, so when it is having the same distance, what does it imply? So can I consider this as radius of a circle then? Because it passes through 3 points, right? So if a circle is drawn, if a circle is drawn with center O, what will happen? It will pass through. If a circle is drawn with center O and radius OA, okay, radius OA, what will happen? It will pass through the points B and C, right? Hello, are you guys there?
Ma'am, how?
It is, see what I have told you, what we proved right now is O is a point. Now this is A, this is B, this is C. Okay, so what we just proved is OA equal to OB equal to OC. Did we prove that?
Yes, ma'am.
So when OA equal to OB equal to OC, if I take OA as radius, don't you think it will pass through all the 4 points? I mean, assuming that's a proper circle. If it is a
Okay.
radius,
Yeah,
it will
I
pass
understood.
through all the points, right?
Yes, ma'am.
That's what they are saying. If a circle is drawn with center O and radius OA, what will happen? The circle will pass through. The circle will pass through B and C. B and C also, right? Eva, Shreya, and Nalin, any questions you have?
No, ma'am.
No, ma'am.
Okay, so now that means what? So that means what? You can write this implies that O is the only point. O is the only point equidistant from A, B, and C. Therefore, you can write, okay, don't draw this, okay? Then write, therefore, one and only one circle can be one and only one circle. One and only one circle can be drawn through points A, B, and C. B and C. A, B, and C are not in a straight line. Okay. So if you want me to scroll up, it's basically I'm copying most of the things from the textbook.
Ma'am, can I scroll down the last part?
Now, see how many perpendicular bisectors are possible for AB. How many perpendicular bisectors are possible? Tell me. Whatever you understood, you tell me.
Does the line go on forever? Like, is it a line or just like
It's a line. It's a line. Perpendicular.
infinity?
Why infinity?
One.
It's only one, no? Because bisector means only midpoint.
Oh yeah, bisect. Okay.
Yes. So perpendicular bisector means only one line will be there. It's because it goes through the middle of the midpoint of that line. Okay. So AB is, assuming AB is midpoint, here it is OP. Now, if I have another line, say B, whatever, BC, assuming it is BC here. Okay. So BC's midpoint, if somewhere is here, okay, from there, the perpendicular bisector will go through one point, one line, right? Perpendicular bisector of BC again is only one line. It might go through O or it might not go through O. It depends. It depends on where is the midpoint coming, right? If BC was such a small line, then the midpoint will be like this. So depending on the size of BC, it might pass through or it might not pass through O. Okay, getting me? So the point which I want to tell you is there is only one perpendicular bisector. Okay, now you need to understand one point here, and that point is mentioned in your textbook. Perpendicular bisector of every chord. Perpendicular bisector of every chord of a circle always passes through its center. Perpendicular bisector of every chord of a circle always passes through its center. Next point is perpendicular bisectors of any two chords. Okay, perpendicular bisectors of any two chords of a circle always intersect at the center of the circle. Okay. Do you understand this? Perpendicular
ma'am.
bisectors of any chord you take that will intersect at the center of the circle. Why? Because all the chords, its midpoint will pass through the center of the circle, right? The center, it will always pass through the center of the circle. If you want to try, you can try, then you will understand. Just draw a circle. Center will be this. Any chord, its midpoint has to go through the center of the circle. There is no doubt about it. So perpendicular bisector of any chord will pass through the center. So please note down those 2 points, and then we will start with numerical problems. This diagram, okay, it's just what I was saying is draw a circle. Okay, just draw a circle. You draw a chord. Any chord you draw. Its perpendicular bisector means what? It has to go through the center of the circle, right? That's what I was saying. Perpendicular bisector to that chord will always pass through the center of the circle. Is it not?
Yes.
That's what I was explaining.
Yes, ma'am.
Yeah. First question is, in the figure given alongside, CD is a diameter which meets the chord AB at E. Okay, so we have a circle. Okay. Now this is center of the circle O. Now you have AB here, marked AB. Then what? CD is a diameter. CD, okay. CD. Okay. CD. This point is E. Okay. CD is a diameter which meets the chord AB at E, such that AE equal to BE equal to 4 centimeter. So AE and BE are 4 centimeter. Fine. If CE is 3 centimeter, this is 3 centimeter. Find the radius of the circle. So radius of the circle is going to be OC, right? What is the radius of the circle? Radius is going to be OC, right? Are you understanding or not? Hello. OC will be the
Yes, ma'am.
radius of the circle. So here, also if I draw, yeah, it's not there. If I draw OB, OB is also radius of the circle, right? OB can also be radius. Similarly, OD
ma'am.
is radius, OA is radius. So you can think in different ways. So here, assuming that this is R centimeter, okay? Take, let me just take it as OB. OB equal to OC equal to R centimeter. What is going to be OE? What is OE? Can you say OE is, what is OE? Can you see what I have? This is OE, okay? This is OE. OC is our radius. Similarly, OB is also our radius. So what is
Will OE be equal to OA or and OB?
OE will not be equal to OA. See, what is a circle? This is the center of the circle. Only you touch the circumference, that will become radius.
Oh, okay.
Right? If it is not touching the circumference of the circle, then it won't be the radius. Okay, so when I look at it, this is assuming this is B, this is A, okay? Here OA equal to OB equal to, this is OC, OC equal to R. Understanding? All these are radii of the circle. Because of that, OA, OB and OC are R centimeter. Fine. Now OC, we don't know the complete information. We don't know the complete information about OC. But partially we know. OC's full value you don't know. What is OC? OC is, if you look at it, OC is OE plus EC,
Yeah.
right? Now, what is OE? OE is, we don't know OE, but we know EC is 3, right? 3 is, EC is 3 centimeter given. Getting me? So when I ask you what is OE, you can say it is OC, that is R minus 3. Can I write like that?
Yes, ma'am.
So Shreya and Eva, did you understand?
Yes, ma'am.
Yes, ma'am.
So I'm writing OE as R minus 3. So this side I'm getting R minus 3. This side I'm having R. Can I use Pythagoras theorem to find out? Can I use Pythagoras theorem? What is Pythagoras? Using Pythagoras theorem, what is the spelling? Pythagoras theorem. R square equal to 4 square plus R minus 3 the whole square. Correct? Yes or no? Now this is going to be what? R square equal to 16 plus R minus 3 whole square is like A minus B whole square. So that is R square minus 2 into 3.
9.
Yeah.
Okay,
Plus,
no, sorry, ma'am.
yeah. I have to write the 3 terms, right? Yeah. So now this will be 16 plus 9 is 25 plus R square. Wait, am I doing it right? Oh, okay. There is a chance I might go wrong. 1 moment. Yeah, this is correct only. Yes. Now what? Plus minus 6R, right? So here R square and R square, if I bring it to one side, it will get cancelled. Equal to 25 minus 6R. So this will be 0, okay? So this will give you 25 equal to 6R, implies R equal to 25 by 6. Are you getting this? Understood or not? Exercise 17A, first one. The question is, a chord of length 6 centimeter is drawn in a circle of radius 5 centimeter. Calculate its distance from the center of the circle. So you have the circle here. Chord is 6 centimeter. Okay. Now the circle's radius, a chord of length 6 centimeter is drawn in a circle of radius 5 centimeter. So radius is, this is the center of the circle. So radius is 5 centimeter. Now the question is, calculate the distance from the center of the circle. You need to calculate this. So if I write A, B, C, you are asked to calculate AC. Calculate the distance from the center of the circle. So what will be chord when I draw a perpendicular from the center? So what will I do first? Draw a perpendicular bisector from the center of the circle. Center of the circle. Okay. Therefore, AC is equal to what? 3 centimeter. Got it? Now, using Pythagoras theorem, what do you get? OC square is what you have to calculate. It will be 5 square. What is it? 5 square minus AC square. What is AC square? I'll just write it, AC square. 5 square is 25 minus 3 square, which is 16. So what is OC? OC is 4 centimeter. So therefore the distance from the center of the circle to the chord is going to be 4 centimeter. So if you did not understand, you can ask me. So what I did here, I used the first theorem. In the first theorem, what we have learned, whenever you draw a perpendicular bisector from the center of the circle, a chord is, its chord is equally divided. Perpendicular bisector means a chord is equally divided, right? So when you divide a chord equally, what will happen? You know, by 2, 6 centimeter by 2 is 3 centimeter. So AC is 3 centimeter. Perpendicular means this is going to be 90 degrees. So you can apply Pythagoras theorem on that. Okay. Now distance from center to the chord means this is what they are asking you to calculate. Distance from the center to the chord. Understood? Any questions?
Yes, no, ma'am.
Nalin, did you understand this?
Yes, ma'am.